G'day students. So this is the final of the chronic adaptations videos, and this one's all about resistance training and changes or chronic adaptations within the muscular system. So we're talking about the skeletal muscles, the ones that pull bones closer together and further apart. So let's get straight into it because I know there's been a lot of information given today. So the muscular changes that occur due to resistance training, and don't forget this means that you have to have done your progressive overload, and this has to have made sure that you haven't overtrained and you've stuck to all of the training principles. So we're talking about things like plyometric training here, as well as just resistance-based training. So box jumps, etc. do count, not just a bicep curl. But mainly what we will see is increases in muscular strength. And a lot of this is due to two things. Number one, you're going to have an increase in the anaerobic substrates. That means the fuels used during anaerobic systems, so phosphate, creatine, etc. And then you're also going to have muscular hypertrophy. Now, hopefully you understand the word hypertrophy. I've been using it all year, and it's about the growth of a muscle. So what you can see here is that if we were to take a pre-trained athlete and look at the amount of millimoles per kilogram, that's the measurement of phosphate creatine or just simply creatine on its own, ATP or glycogen inside a muscle, there's the numbers that you're looking at there. And if you were to take the same kilograms worth and look at the amount of millimoles after a 6-week training program, those are the numbers you're left with. So instead of just looking at a number difference, because we can see that there's different amounts of stores, we look at a percentage difference and look at size of and differential of growth. And you can see that the amount of loose creatine and the amount of glycogen and the amount of stored ATP ready to go inside the muscle has increased by 35, 32, and 17.8% with heavy resistance training. So there's a huge amount of anaerobic substrates that are sitting in that muscle ready to go after someone's completed resistance training program. So what we also need to understand as well is that while muscles go through hypertrophy and grow, they also go through atrophy and decrease in size if they're not used. Now, the speed in which this happens is different from person to person, depending on genetics, how well that person's eating, how much protein they're consuming, whether they are maintaining exercise or not. But I mean, we've all seen this happen before when somebody breaks an arm or breaks a leg and their arm or leg goes into a cast. And once it comes off after 6 weeks and that muscle has not been used, it has shrunk and it will grow back. When we talk about things like environmental factors, we're talking about the person's job or workload. And so they might not be going to the gym and completing resistance training. But if, for example, they're a tradie and they're lifting heavy mounds of soil or bricks or something all day long, that's putting the muscle under stress as well and will help maintain this. What is really interesting, though, is that if you start a resistance training program, within days or the first week or so, you will notice that the force generation within a muscle will have a very quick change. However, the muscle may not grow in size, and this is all due to the neural adaptations, which is the changes that happen for the brain to be able to communicate with a muscle and have it switch on effectively. So what we need to understand from this top little section here is that yes, the muscle will grow in size, but what that does is it increases the capacity for that muscle to generate force. However, those neural changes change the effectiveness of muscular coordination. So if a muscle is becoming more effective, it's due to the neurological change. If a muscle has more capacity to create force, it's due to the hypertrophy. So the neural adaptations, these, as I said, are the initial changes in strength. Okay, so you can see this graph here. Hypertrophy doesn't kick in for a little while, and when it does, it's a slow climb all the way up until the muscle hits its maximum hypertrophy state. However, this line here is the performance of the athlete, and it shoots straight up. And it's shooting straight up much faster than hypertrophy is taking place. And that is because these neural adaptations that I'm about to talk about happen very rapidly at the start and then they level off because your brain gets to its maximum communication capacity within a muscle site. So that initial change is all due to that neurological adaptation, and then the serious strength trainers afterwards that go through this hypertrophy will gain that extra strength. And you can see how steroids gives that excess right at the end, but it is very dangerous to the human body. So let's go through the neural adaptations because there's some interesting stuff in here that some of you might find quite difficult to grasp, and I'm happy for you to ask me questions afterwards. So I'm not going to read through each of this list. You can go and check that yourself because it all goes through in these paragraphs down here. But essentially, with resistance training, you are able to have a larger amount of motor units recruited. And when that happens, muscles can produce a greater force. Remember, the motor units is that one message, that one unit that travels from the brain down to the muscle and recruits a muscle fiber to actually contract using actin and myosin. We learned that in year 11 PE. So if you're able to generate more motor units and recruit more motor units, you're going to be able to recruit a greater force of muscle. The next one is about the ability to recruit the higher threshold motor units. And so muscle fibers themselves, with resistance training, you're going to be able to generate more fast twitch fibers more regularly than slow twitch fibers, which will help in generating more force within a muscle and therefore show more strength and potentially more muscular power as well, if we are able to generate the motor units to recruit the fast twitch fibers. Resistance training will also increase the firing rate of a motor unit, which will help with strength and duration. And I'll get you to cast your eyes down to this diagram here. As you can see, this is before training when the brain stimulates one motor unit message to switch on the muscle. And when we talk about the firing rate, that brain is just firing off motor unit after motor unit after motor unit to switch that muscle on using more fast twitch fibers, and also each of those messages telling that muscle, stay on, stay on, stay on, stay on. The actin and the myosin are using more ATP to contract a little bit longer, and that helps with the duration of that muscular contraction. Elite athletes, you will notice when you watch them on TV, they perform real powerful movements with perfect timing, and it doesn't look difficult. Little apparent effort. And this is due to the increased motor unit coordination. So what that means is that if we do plyometric resistance and we're getting those explosive muscular contractions where they stretch out nice and quick, the nervous system develops reflexes to these high stretch loads. And so the co-contraction of an antagonist muscle will increase and help with stabilization. So what we mean in this one, and it's quite a difficult one to understand, is that by doing plyometric, things like box jumps, etc., where it's not just sitting and doing some quadricep curls. The quadricep is being used, but the hamstrings are also having to be used during the stabilization of the landing and even to part of the takeoff with that downward phase. And if this is occurring, then what's happening is that co-contraction is taking place a lot more smooth and a lot more effectively. The brain gets more practice at generating both the quadricep and the hamstring muscles to be switching on and off, because more motor units are able to be sent, and therefore there's much more of a smooth transition between the switch on and the switch off of both the quadricep and the hamstring, the agonist and the antagonist, when we complete a movement. And this leads to how elite athletes are able to make those movements look so effortless because their brain has had so much practice at sending the right messages in the right timing to recruit the right fibers of each muscle at the right time. So that's what that one's all about there. So the increased synchronization will lead to a smoother acceleration of the body. The last one here, and it's one of these bold words, and some people might not know what the Golgi tendon is, But the Golgi tendon organ is the part of the muscle that actually stops the muscle from trying to contract too much. So a Golgi tendon organ will prevent a full contraction of a muscle. So if you were to flex your bicep, you will notice that the bicep doesn't totally collapse in on itself. However, if you look at some of the photos of Arnold Schwarzenegger when he was at his absolute prime, and you look at the way that his bicep tendon actually compacts in on each other and gets that real big bulge, that is because his Golgi tendon organ has been inhibited, allowing his body to generate that bicep to be able to bunch up into such a ball and generate that much pull from bone to bone. So resistance training will inhibit the action of the Golgi tendon organ and allow for more forceful contractions. Feel free to pause the video and have a look at that table about what increases and what decreases, but anyone who's very, very intelligent, which I know you all are, can look straight away and see that nothing decreases inside the muscle with resistance training. It is all increase. So the final section here is about the hypertrophy, and it's a section that I know I've mentioned what's in this FYI box 1,000 times, and I know that you should all know the definition of hypertrophy, but we do need to look at what's actually happening. So muscle growth is a result of injuring the muscle fiber and overcompensating with protein. We've spoken about the little tears that occur in our muscle, and when those little tears occur, if we eat our protein, then they fill, and they'll fill with a larger, more stronger muscle. So if we're actually looking at how does a muscle go through its hypertrophy phase, we need to look at these three things here, and they're detailed in these paragraphs. So there is an increase in the cross-sectional area. That means if I was to cut a muscle in half, right down the guts there, and then look at it front on, it would be an increased size. This is due to the number and the size of myofibrils increasing. However, the actual fiber does not change. To explain this, have a look at this diagram. This is a muscle fiber. Inside the muscle fiber, we have sarcolemma, mitochondria, etc. And we have each of these individual myofibrils. They are the ones that increase in size and in number. However, this fiber itself will stay as one fiber. Okay, so that's an interesting one to understand there and to note. So as the myofibrils will increase, it is actually the fast twitch B fibers that increase the most. They're the non-oxidative ones. And this means that there will be a higher number of actin and myosin, which is these contractile proteins, inside those fast twitch fibers, which leads to more of that coupling and that pulling together. If there's more actin and more myosin, there's more cross-bridging and generating of force because more fibers are grabbing together. That means the muscle becomes stronger. More larger fiber size means that, or more larger myofibrils leading to a large fiber, leads to the capability of being able to store more ATP, more PC, and more glycogen, which means that we can provide more rapid intensity energy for high intensity activities. Finally, the connective tissue, so the tendons and the ligaments within the body, will thicken and strengthen. That means that we don't need to be afraid of the fact that if my muscle fiber can generate a huge amount of force, it is not going to pull off the tendon if I lift a weight that's too heavy, because the tendon that's attaching onto the bone itself becomes stronger to withstand that big muscular contraction. They're all the changes within the muscular system due to resistance training. I hope you've understood them. Feel free to join the Zoom. Up on Compass, there are some practice sacks now, as well as completion of the peak questions will really help you in the sack next week.